Hola amigos! Welcome to the second video in this Substance Designer course. In this tutorial, we'll take a deep dive into one of the most useful nodes in the library, the tile sampler. Before we begin, let me rearrange the UI a bit by moving both the library and Explorer panels out of the way and into my second screen to have more edit space. Next, I'll create a substance graph using the metallic roughness template. I'll name it Tile Sampler Tutorial and leave the rest of parameters to default. I will also change the scene mesh to plain high-res and the material definition to metallic roughness, tessellation plus displacement, and then increase the height scale and tessellation on the material parameters. On the graph, I will add a blend node with the opacity set to 0 and connect it to the normal and height nodes. Finally, I will add an ambient occlusion node and connect it to the appropriate output. In future videos, I will start with the same setup and skip these steps. Note that I temporarily connected a uniform color node to the blend node to set it to grayscale mode and prevent errors. The connectors on nodes have different colors based on their mode, yellow for color and gray for grayscale. Now we can get started. Add a tile sampler node and connect it. I'll go over the parameters first and then we'll use it to make a few different patterns. The tile sampler is a powerful node used to scatter shapes on a grid. At the top of the parameters panel are the controls for resolution, aspect ratio, color depth, and tiling. The random seed can be used to generate new outputs without changing any of the other parameters. On the instance parameters section, the first values are the amount of shapes to scatter on both x and y axes. Note that the shapes change size when modifying these values, since they are distributed over the entire texture. For this first pattern example, set the x amount to 2 and the y amount to 16. On the pattern section, the first parameter is the shape to scatter. The first option allows you to provide your own shape, and the rest are the most common ones used. For now, we'll keep a square. The pattern-specific parameter allows controlling some aspects of these shapes, like gradient center points. This parameter is context sensitive and doesn't show up for all the available shapes. The options for rotation and symmetry modify the shape before distributing them. Since we'll be using a square, this will have no effect. Next, size mode controls how the shape is scaled, and we will keep it on normal for this example. The next two parameters control the size of each instance of the shape independently for the x and y axis. On the other hand, the scale parameter, a bit below, affects the scale of each shape uniformly. For now, set the scale to 1 to have the squares occupy the whole texture, and then reduce the x and y sizes until you get a gap a few pixels wide. You might want to have a bigger separation than what I'm showing here. That will be useful later. Size and scale random allow you to randomly scale each instance. The closer these values get to 1, the higher range of random values is used, all the way to 0. The next two parameters affect map inputs, which you can use to sample the shape scale values from other textures. We'll see all about those in the next video, so let's skip them for now. With position random, you can offset each instance in a random direction. Note that the sampler node doesn't care about their sizes, so they start overlapping almost immediately. Offset displaces all the instances in each row or column as a group. Offset type controls the axis and the way this displacement is applied. Set it to horizontal quincunx and the offset to 0.5. The global offset moves the whole pattern, and afterwards the rest of parameters correspond to map inputs, so we will ignore them for now. Rotation and rotation random are self-explanatory. Note that with big shapes, it is also very easy to run into overlapping issues, although this can be used to produce interesting patterns as well. In the color section, after more of these map parameters is the mask random. This allows to remove random instances from the pattern. This mask can also be inverted with the button below. The blending mode only affects the result when shapes are overlapping. To show how it works, I will also increase the color random parameter in order to get some variation in the tiles. When using the max blending mode, only the highest value is kept. The add/sub mode uses additive or subtractive blending based on the shape values. Now that we know how most of the parameters function, let's make some more patterns. For the first one, we'll keep it simple. Without removing the previous one, add a new tile sampler and set the X and Y amounts to 2 and 16 respectively. Next, set the scale to 1 and the rotation to a 45-degree angle. Finally, play with the X and Y size values until you get gaps a few pixels wide. Again, leaving a bigger gap than my values in this example will pay off later. For the next pattern, add a shape node. Keep it as a rectangle and set its Y size to 0.2. Next, add a tile sampler node and connect the shape to pattern input 1. Change the filter mode to nearest to keep the crisp edges. Set the scale to 1 and then the X amount to 15 and the Y amount to 4. This time, we're going to use a vertical global offset type. Set the value to 0.2. Now, we can go back to the size values and adjust them until you get something like this. In my case, I used 1.94 for X and 0.94 for Y. To fill these gaps on the pattern, we need a copy of the previous shape. But instead of duplicating the node, we are going to use a transformation 2D to rotate the shape 90 degrees. Now select the tile sampler that we just made and press Ctrl D to create a copy. Now replace the pattern input 1 with the transformed rectangle. Now we need to adjust some of its settings. First, set the X size to 4.75 and Y to 0.58. To make it easier to set the second set of parameters, blend these two tile samplers together with an add mode. While keeping this blend on the 2D preview, it is much easier to adjust the offset and size to create the pattern. Now that we have a few nice looking patterns, you might be thinking, it would be cool if I could add those to the library and use them later, right? Well, yes you can. Let me show you how. First, we need to save the patterns as separate graph on the same file. But before that, we need to add an output node to each one, so we have something to connect them from. In the third pattern, remember to add the output node after blending the tile samplers. Now repeat the following steps for each one of the patterns. Select the nodes that make the pattern, including the output, then right-click on any of them and select Create Graph from Selection. The number in parentheses indicates how many nodes are selected. After giving it a name, the new graph shows up in the Explorer panel, and can be added back by dragging and dropping it into the graph view. To make these graphs appear in the library and be accessible from other files, first we need to tell Substance to include the folder where this file is saved when searching. From the top main menu, select Edit Preferences, open the Projects settings and go to the Library tab. Next, click the plus icon to add the path where you save the tutorial file. You can check the recursive option to include all the subfolders inside the one that you selected. Now, we need to create a filter for our patterns. In the Library panel, click the top left icon to add a new folder and give it a name. Then, click the second icon to add a new filter. Select Graph as the type of object to search for. We are going to add all the items with a name that contains the text tile_pattern. You can rename the filter itself and change its icon. Remember to change the search text if your patterns have a different name. After saving the file, our new patterns show up in the library under our custom folder and can be used in this or other projects. In fact, many other nodes in Substance can be opened and explored to understand how they work or to make your own variations of them. We still have time to make a few more patterns. For the next one, I copied the tile sampler that we use on pattern number 2 with the diagonal tiles. Change the X amount to 1 and set the X size to 0.7. Next, duplicate this tile sampler and change the rotation to 135 or -45 to have the opposite diagonal. Now blend these two together using the additive mode and set the global X offset to 0.5, not the offset per instance. Finally, adjust the X and Y sizes until you get a pattern like this one. Like I mentioned a couple of times, we are going to bevel these later, so make them a little bit smaller than what I have here. I will keep adding this to the library to maintain things organized. If you do so, remember to add an output node before saving the nodes as a graph, or they won't have a connection point. The next pattern will use two different shapes. Start with a square and set its Y scale to 0.98. Then add a transform 2D and set the Y offset to 0.5 to have this gap in the center. We also need a vertical copy, so add a second transform and rotate it 90 degrees. By default, the tile sampler only takes a single shape. However, this value can be increased once you set it to use pattern inputs. Set this number to 2 and connect one of the transforms to each one. For the rest of parameters, set the scale to 1, the X and Y amounts to 8, and the X and Y sizes to 0.98. As you can see, the tile sampler is currently choosing each instance randomly from our two inputs. To correct that, change the pattern input distribution from random to pattern number. Finally, set the offset to 1, and we have another pattern that we can add to the library. For the next one, we're going to use a shape not available in the tile sampler. Add a polygon 1. Since hexagons are easily tileable, you can leave all the parameters to their default values. and you know what comes next. Add a tile sampler node and use the polygon as pattern input 1. Now set the offset to 0.5, scale to 1, X amount to 8, and Y amount to 10. After some adjusting on the X and Y sizes, we have another nice looking pattern. Add it to the library and we can move on to the next one. Now we're going to make a cool variation on the previous pattern. Start with a square shape, rotated 45 degrees. Next, add a transform 2D and scale it vertically until it's around half the size. We only need one, so set the tiling mode source to absolute and the mode to no tiling to fix this. Next, add a splatter circular node. This one acts similar to the tile sampler, but distributes shapes in circles or spirals. Connect it to the transform and change the pattern to use it instead of the default circles. Set the pattern amount to 3 and the scale to 0.8 or so. To have one of the vertices point up, set the ring rotation to 30 degrees. You might need to go back to the transform and adjust it to get parallel lines, like I'm doing here. For the next step, you can copy the previous tile sampler and replace the pattern input with this new broken hexagon, or recreate it anew, like I'm doing here. Either way, you can add it to the library when done and remove the nodes to keep things clean. The last pattern that we will see in this video will be formed by combining some circles. Start with a shape node and change it to a disk. Afterwards, add a transform 2D node and manually set the offset X to 0.5 and the Y to minus 0.5. Set also the tiling mode to horizontal to remove the top quadrants. Now, use a blend node to subtract one from the other. Remember to connect the part that we want to remove on the top input of the blend. Moving on to the tile sampler parameters, set the X amount to 4 and the Y amount to 8. Scale should be 1 and offset 0.5. To complete this pattern, adjust the size to leave a small gap between each shape. Once you're satisfied, add it to the library and let's see what can we do with all these patterns. To start, choose your favorite pattern and move the rest out of the way for now. Next, add a bevel to remove the hard edge. This will expand the shapes, and it is the reason why I recommended earlier to have a wider gap. Since this is going to be a quick and dirty material just to show how you can use these patterns, I didn't plan ahead and had to go back and adjust the sizes to avoid some artifacts. Set the distance to a very low value, like 0.01. Using a bevel like this or a low intensity blur will remove the issues caused by hard edges like this. Let's add some edge noise to the tiles, using a Clouds 2 and a slow blur grayscale. We'll see this node in more detail in a future video, but you can think of it as blurring not the entire texture input, but only its height differences, aka the slope, which in our case is just the edge of the tiles. Now increase the samples to the maximum value and the intensity to a low value, like 0.5 or so. As you can see, it's blurring the height map both towards and away from the tile center. To change that, set the mode to min. And to make it a little chunkier, we can reduce the resolution of the clouds noise a couple times. Select the node and set the output width and height to -2. We could connect the slope blur to the main outputs directly, but I just want to have a bit of edging, so let's blend it on top of the main map instead. Set the mode to copy and the opacity to something around 0.25. Remember to connect the noise on the top input to make it the one controlled by the opacity slider. And here I'm just reducing the roughness to make the noise a bit more noticeable. The next node that we'll see is called a float fill. Add one and use the base pattern without the bevel as input. As you can see, this has flooded each shape with a gradient fill. Apart from colorful, these gradients are information that can be used in a series of nodes to manipulate each instance or give them different values. The main limitation of this node is that it only works on watertight shapes, but our tile patterns are perfect for it. If you start typing float fill on the node search window, there are quite a few options. For this first example, select float fill to gradient. By default, all shapes will have the same horizontal gradient. Increase the angle variation to give each one a different value. If we now blend this with the main height using the min darken mode, each tile will rotate in the direction of the gradient. We don't want to overdo it, so lower the opacity a bit, maybe 0.3 or 0.4. To prevent some problems with the bevel, let's use it as the input of our float fill instead. However, as I just explained earlier, this node expects watertight shapes, so we also need to add a histogram scan between the bevel and the float fill. Increase the contrast to 1 and set the position as high as you can while keeping some separation between the tiles. Our goal here is to make sure that the float fill doesn't fail while having a mask as accurate as possible, and that means including the bevel. If you have problems with the float fill, you can try the no failure mode or go back into your patterns and space the tiles a little bit. With that out of the way, add now a float fill to random grayscale and connect its input. We will use this to break the cloud's noise per tile without distorting it. Add a directional warp and use the clouds from earlier as the input and the random grayscale as the intensity input. Since we downscaled the clouds earlier, but it's the main input here, you will have to reverse that and upscale the warp to keep the resolution intact. Let's zoom in the noise texture and set the warp intensity to a really high value, like 3 or 400. This will break the texture and essentially show a different part of it on each tile. The edges are now completely distorted, but they will be masked anyway. We're going to overlay this noise on the sunken part of the tiles. Add an invert grayscale to the random gradient to reverse its direction before blending it. Set the mode to overlay and leave the opacity at 1. And before blending all this back into the main height, add a levels node. This will let us control how much of the effect we apply and how soft or hard it looks. And now we can blend it, using again the min darken mode, and afterwards go back to the levels and adjust the sliders until you get something you like. Let's make a quick ground layer by blending two different dirt noises and adding a histogram range to control its intensity. To combine it with the height map, use a height blend node. Set the contrast parameter to 1 and adjust the height offset until you get a good amount of dirt showing through the broken tiles. Now let me go back to the histogram range and the two blend nodes and adjust their settings. A cool aspect of the height blend node is that it also outputs a mask of the two layers. We are going to use this mask to blend a fractal sum base noise, but only on top of the tiles. First, use an invert grayscale, and then add a blend node set to multiply. Finally, connect the fractal sum and the height mask to the top and bottom inputs of the blend respectively. Set its opacity to 0.05. We could spend hours adding more detail, but let's finish this material for today, adding a pair of gradient map nodes to create colors for the dirt and the tiles. Using the peak gradient technique that I explained on the last video, I first made this brownish gradient, which will use the fractal sum base as input. For the second one, I chose a photo of cobblestone tiles. This one uses the flood fill to random grayscale as input to have a single color per tile. To mix these two, add a blend node set to copy using the same mask that we used earlier to separate the tiles and the dirt. If all this last part seemed complicated, don't worry, we'll have videos dedicated exclusively to color and roughness maps. I don't want to end the video without showing the true power of NodeGraph-based software. Go back to the beginning of the material and hold Shift and drag the connection from the tile pattern to any of the other ones, to see how the effect looks on them without having to redo the whole graph. In my opinion, this type of quick changes alone justify switching to editing tools like Substance Designer or any of the other ones in the market. That is all I have for today. If you stayed this long, thank you for watching this long video. In the next one, we'll see how to use the tile sampler to make more natural looking patterns. See you next time!